All right, so we are discussing the conditional probability. So identify the conditional probability, also aka known as the given probability. This is a probability that an event occurs given that a first event has already occurred. So basically, you already know something. So you already know something. This is the notation where it's just this single line here. So you know, like, and, sorry, let me just erase that. And is this symbol, or is this symbol. This symbol right here, the straight line down, is what we call the given or the conditional probability. It's straight up and down. It's not sideways or angled. That is the conditional probability. All right, that's the notation. There's a formula for it. If you know the probabilities, it's the probability of the intersection of them both occurring dividing by the probability of what you already know, or the given. So what you're going to notice here is the denominator changes. So this isn't, let me write that. This is the only time your denominator is not the total number of people or total number of items or whatever that you're choosing from on the bottom. It's going to change because you've narrowed it down and you know that the bottom number, you already know something about it. And that's what the difference is. If you don't know the probability, then it's just without the probabilities. So it's the probability of A and B, or just A and B divided by B. So how many are in the intersection divided by how many are in the what you already know. And what we always say, it's the and over the given. So this is the and, the intersection, the two things occurring, and that's the given, the thing that we already know occurred. That's the formula. So that's like the shortcut way of saying what the formula is. So let's just do a quick Venn diagram. Woo, yay, Venn diagrams. We have two items here. So we have people that play volleyball and the people that play rugby. 18 people play volleyball and 17 play rugby. So they'd say that 27 people play volleyball or rugby. So that's our formula. We just use people that play volleyball plus rugby minus volleyball or rugby. And this is going to give us our intersection here that we love so much. And so we can get all of our other items. So it's 18 plus 17 minus 27. And so that is 8. So I know that this intersection right here is 8. So I know the full circle for volleyball is 18. So just play volleyball is 10. 8 people already we know play rugby. So we have 9 left here. Add all those up. We get, 20... I got this, 25. Yeah, whatever. I know I have 5 left here. I didn't show my work on my note sheet. So that's 20, that's 17 and 10. That's 27, right? That's your or. And then we have 32 people. So that's 5 people don't do either. It's okay. I got this. So now we got to answer a question. So this is our notations. Instead of using words, we're using this, of course. So the P on the outside means this is probability. So one's the normal probabilities that we know. The total's on the bottom. So the total was 32 people. So I know the bottom number is going to be 32 for all of these. Because these are just regular probabilities. These, however, the probabilities are going to change because it's the given probability. So this is the probability that someone plays rugby. So that's the full circle of rugby. So there's 17 people, so it's 17 over 32. Rugby and volleyball, we know that that is this number right here, so it's 8 out of 32. Rugby or volleyball, So that's the circle of the 2. That's the 27 that we have up here. So that would be 27 out of 32. And just play volleyball. Not just volleyball, but play volleyball. That's 17 out of 32. Oh, 18. My bad. That was 18 out of 32. All right. Now the given. The given here, you have to remember, it's the and over the given. And the given is the second one. So the denominator, I always do the denominator first. And then out of that denominator, I find the top one because that's where the intersection is. So how many people play rugby? That's your bottom number. So that's 17 for this one because this is the given. Okay, so that's your bottom number. It's the and. I'll write this out again. Oh, blah, 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 blah. So it's the volleyball and rugby divided by just how many people play rugby. So the people play volleyball and rugby, that's 8. And the probability, and then the people that play rugby is 17. So this one would be the same thing. So rugby and volleyball, is the same as this. So that top number is going to be the same. But this time the second one is volleyball. So it's out of 18 because it's volleyball. So we know, so what's the probability that someone plays rugby given that they already play volleyball? So we already know they play volleyball, so it's only picking out of the people that play volleyball. So these ones get a little bit more involved, and we just like to test your, how much you get of this. Okay, so this one is the probability plays rugby and not volleyball, divided over the people that do not play volleyball. So let's look at this. So people that do not play volleyball. So if you recall, these are the people that played volleyball. So not is everyone that doesn't play volleyball. All right. So if you don't, so all the people that don't play volleyball are the ones that I colored in. So that's 9 and 5. So that's 14. Out of those people, how many people play rugby? So that would be 9. Okay, so rugby and not volleyball is 9, and that's 14. I get it, Miss Barris. It's so easy. And I don't think I can unhighlight that, so you're just going to have to deal with a different color now for the next one. So for the next one, we have volleyball and not rugby divided by not rugby. So we circle, or let's just do green. So the people that play rugby, those are the people on the bottom. That's rugby. Everyone outside of that is out here. That's the green. Oh, this is so pretty. So everyone that's colored in, that's the 10 and the 5. So that's 15 for the bottom number. And then the top number is out of those people, how many also play volleyball? So that's 10. So hopefully that makes a little bit of sense. But if you can get these, this one and this one, you probably got a good handle on Algebra 2. Okay, so let's go through with the table. So you do have to fill in the table, so why don't you pause for a second and fill in that table. All right, so I filled in my table. Hopefully you didn't have any issues with that. And you're looking at a table that we have people that are visiting or make bookings to visit France, Spain, and Germany, and whether they're going to be taking a car or ferry, and a plane. Okay, so that's the probability. The total number of people, the total number of people is 40, and all of the things add up. So what we're trying to do now is do some probability, and we're going to work into the conditional in a minute. We're going to figure out if it is the conditional. So probability that someone picked at random, that should say at random, is going to France. So someone picked at random is going to France. So we don't know any extra information. So we know that the bottom number is going to be 40 because we don't know If maybe someone is already know that they took a plane or something. All we know is that this person picked at random is going to France. So we don't know any extra information. So we know the bottom number is 40. Total number of people that go to France are 18. And that's it. Probability that someone picked at random is going to France or Germany. So we're not sure if we already know something. Do we already know that this person went to France? No. Do we already know? No. They went to France or Germany. So the bottom number is 40. So we have to figure out France or Germany. We have 18. We add the people that go to France plus the people who went to Germany. We subtract their intersection. Well, you can't go to France and Germany, so there is no intersection. So it's just 26. Probability that someone picked at random is going to France or taking a plane. Okay, so this again, it's just an or question. It's not I already have information, so I know my bottom number is going to be 40. France or taking a plane. So if we look at France, this is France column here. This is France. Taking a plane is here. So we just have to figure out how many of those people there are. Now, the way that we do this we can just use a basic formula. It's 18, add the people that go to France, plus the people that are taking a plane, and we subtract their intersection. Okay, so people that go to France are 18, people that go taking a plane are 12, and if we do that, we've counted this 3 twice. So in the 18, there's 3 people. These 3 people were counted, and in the 12, these people were counted. Okay, so that's how that's what we're doing. We're subtracting that overlap, and that's allowing us to find out the or. I don't know why I'm coughing so much. Alrighty, so all of these had that denominator of 40 because we didn't know information prior. So now, if we look here, it says given a person went to. If you see the word given, you know it's the given probability. It's just telling you. Given a person went to Spain. So we already know this person went to Spain. What's the probability that they went on a plane? Because it rains in Spain. So Spain, what we want to do is we know that they went to Spain already. So that's the given, they went to Spain. So what's the probability they went on a plane given they went to Spain? So I guess I could do it the other way. So plane and Spain over Spain. That's what we want to know. So I just have to scroll up a little. So the probability that they went to Spain, I'm going to use a different highlighter color, is 14. Okay. Or how many went to Spain. So the denominator is 14. So the probability went to Spain and on a plane is this spot right here where all the people, where the Spain and plane intersect. Here and here intersect, so that's 6. So this particular question is 6 out of 14. Okay? If someone chose it at random, sorry, that was awesome. Just minimize that a little so I can see this at the same time. So what we have here, if someone chosen at random flew on a plane, what is the probability they went to Germany? So this isn't something that I'm telling you that I know something. So you have to be able to tell that did something happen first before the second thing happened. So is this an and or is this a conditional? If someone chosen at random flew on a plane, so I'm telling you already, I know they flew on a plane. So I know that this is given. I know that they flew on a plane already. What's the probability they went to Germany? Okay, so that's what I'm trying to figure out. So that's Germany and plane divided by plane. So Germany and plane, that's 3. And just plane is 12. That's the total. Okay, and finally we have this one. Probability that someone went to France, that someone that went to France took a car or ferry. So it's not using an if, it's not using a given. You just have to be able to tell that this isn't the probability that someone went to France and took a car or ferry. We already know that someone went to France. So that's my given. So it's the probability, that's what we want to figure out, that someone that we know went to France took a car or a ferry. So that's car or ferry and France divided by France. So France is the denominator. So that would be 18. And car and France, that's your 15. Okay, so we'll practice this later, and we hope you have a wonderful day, and see you later.